Okay, welcome to another Crime Pays lecture. Today it's on a subject near and dear to my heart, the rock serpentine, the mineral serpentine, which I got right here. Look at the beauty. You always bring rocks. Always, you never know. If you're in a weird place with some weird rocks, always pick one or two, right? Even if the sign says don't do it. You get a good chunk, a good one. You're not hurting anything by taking rocks. Get a good size, not a little tiny one, whatever you can fit in your pants or your suitcase. Okay, anyway, that aside, let's talk about serpentine because it is one of the rock types that actually causes new plant species to evolve. And how does it do that? It's a fucking bizarre trait, but it legit causes new plant species to evolve. It's responsible for what we call edaphic endemism, meaning endemic. If a plant is endemic to some place, it means it only grows in that place, that region, that state. There's a Texas endemic, Silphium albiflorum. There's plenty of California endemics. There's, you know, but there can be endemics that are restricted to a certain kind of. Is this music too much? Maybe I like it in the background. But there can be endemics that are restricted to a certain soil type. Gypsum endemics, limestone endemics, and the most grandiose of all, serpentine endemics. You can also have laterite endemics and dune endemics. You get a whole different trait of plants on sand dunes, etc. But let's just cut to the fucking chase here and talk about the mineral serpentine. So I first learned about serpentine when I was living in California. It's the state rock of California due to the fact that it can sometimes contain asbestos. Some nerds, some senators, some thin-skinned senators in the '90s or maybe it was early 2000s said that they decided they wanted to not make it the state rock anymore, and it pissed off a ton of geologists. They told the politicians to go fuck themselves and made some like official decree declaring it the state rock. And thank God they did. Don't piss off the geologists, man. Serpentine's a cool rock. What is it? It's ultramafic. What does that mean? Mafic refers to magnesium and iron. Fe, the chemical symbol for iron. So there's a whole spectrum of rocks: felsic, mafic, ultramafic. Serpentine is an ultramafic rock, and it weathers to produce an ultramafic soil. What does this mean in terms of plants? It's toxic to plants. It's high in heavy metals like chromium, nickel, iron, but it's low in essential plant nutrients like nickel and phosphorus. In some of these fucking landscapes, these serpentine landscapes are so toxic to plants, it just looks like this rock, for miles. They're so bizarre. It's like literally serpentine barrens. You get it in California, but it's not only in California. California's probably got some of the biggest deposits of it. The island of New Caledonia off the northeast coast of Australia has a lot of serpentine or serpentinite soil. Serpentinite's the mineral. Borneo also has serpentinite. And Cuba has a little bit of serpentinite, ultramafic soil. So does Dominican Republic. I've seen it there. There's some in Pennsylvania, really old stuff. But generally, wherever you get serpentine, it's there because it was put there by a subduction zone. So to talk about serpentinite and serpentine, we have to talk about plate tectonics, which is what we're getting right here. So here's the plate tectonic map. The lines with the little arrows, those are the subduction zones. And these little jagged lines, like stitches on a baseball, okay, are seafloor spreading centers with transformed faults in between them. The San Andreas is a grandiose ass transformed fault, probably the biggest in the world. And these little stitches in between these lines of the seafloor spreading center down here, right beneath where it says Nazca Plate, those are mini transformed faults. So that's the only map that counts. The only map I ever pay attention to. All right, who cares about geopolitical boundaries? They're stupid. Humans made them up. Tectonic maps are the maps you should be paying attention to. They explain why certain continents are where they are, where they're moving on a scale that dwarfs the human lifespan, and further, why certain plant lineages exist where they do. Okay? Like you learned, South America was connected to Antarctica, and it was connected to Australia at the other end of Antarctica, and that explains why a lot of plant families like Proteaceae, etc., occur where they do. There used to be eucalyptus in South America as well. Anyway, at least according to the fossil record. It also explains why Welwitschia occurs in the fog deserts of Namibia, but there's fossils of it from eastern Brazil. Okay, so going back to what a seafloor spreading center looks like. So this is seafloor spreading centers right here. This is where new crust is produced. This is where old crust gets recycled. The lifespan of oceanic crust is about 200 million years. Notice I said oceanic crust because the continental crust doesn't get recycled. It generally doesn't hit these subduction zones. It's lighter weight, all right, and it just rides on the oceanic crust, generally speaking. So 200 million years from seafloor spreading center to subduction zone. And that's exactly what's going here. You can see on each side, half goes towards the Pacific plate, half of the new crust being produced here, and half goes towards the Nazca plate. Then it gets subducted down here at the western edge of South America, goes back towards the mantle, just like you see here. Okay, so everybody got that? You got these seafloor spreading centers. You got the mid-oceanic ridge. And you've got new crust coming up. Some goes to the west, some goes to the east, or whatever, each way. And it gets recycled back in a subduction zone. Okay. Right here is where serpentine forms. Okay. So serpentine is a cooked form, it's a metamorphosed form of a mineral called peridotite, which you see right here. Okay. We've got this whole spectrum of igneous rocks. You've got the intrusive igneous rocks, granite, diorite, gabbro, peridotite, etc. Probably not familiar with diorite or gabbro. That's okay, but everybody knows what granite is. You get one of those McMansion tract houses, you got to have that granite countertop, right? It's a large grained, that means large crystal size igneous rock. The crystal size is large because it cooled slowly underground. Sometimes it took 1 million or 2 million years to cool. Rhyolite, andesite, basalt, everyone probably knows what basalt is, etc. They cooled relatively slowly. They've got a small grain size. There's crystals there, but they're very small because this cooled quickly. It cooled from a lava. All right. And what these left to right mean are different mineral recipes. Okay, so you've got more feldspars, which is just aluminum silicates on the left right here. Plagioclase feldspar in the center. Feldspar just means generally aluminum silicate. They've got more silica. Okay, whereas you start going towards the right here, you've got less silica and more magnesium and iron. Remember, see, so felsic means higher silica content, intermediate is in the middle, and then mafic means magnesium and iron, and then ultramafic means a lot of magnesium and iron. And that's where peridotite comes in. It's lots of magnesium and iron, and also the minerals olivine and pyroxene, as you can see here on a chart. So that's what our protolith, the rock that exists before it gets cooked or metamorphosed, subjected to pressure and temperature, high temperature, high pressure. All right, so peridotite gets metamorphosed and turns into serpentine. And where does it get cooked at? It gets cooked right here. As it's going back, as this oceanic crust is going back down into the mantle. And so peridotite, you don't really get on the surface of the earth that much. It's pretty rare because it's mostly this heavier oceanic crust. All right, so it normally just comes up, it's puked up at a spreading center, and as it continues moving, just like on a conveyor belt over a course of 200 million years, give or take, then it hits the subduction zone, goes back down. But as it's going back down, it gets hydrated, that is mixed with water and cooked a little bit, and so it produces serpentinite, which is a hydrated mineral. That doesn't mean there's actually liquid water in the mineral. It just means that H2O is incorporated into the mineral's crystal structure. It's the same thing that happens with gypsum. Talc is a hydrated mineral as well. Anyway, so serpentine's produced in subduction zones. You have serpentine anywhere on the earth, there was a subduction zone there. Okay, there was a subduction zone before the San Andreas Fault was formed. There was a subduction zone in Central and Southern California, as well as in Northern California. There still is the Juan de Fuca plate being subducted beneath the North American continent in Northern California and Oregon. That's why you've got that volcanic chain. That's the other thing about subduction zones. You get volcanoes inland from wherever they are, just like you see right here. See the volcanoes, right? So anyway, seafloor spreading centers, subduction zones. And the subduction zones produce the serpentinite. Seafloor spreading centers produce the peridotite, which then gets cooked at a subduction zone into serpentinite. See a nice little diagram showing how the oceanic crust gets recycled. All right, there's our igneous rock chart. And there's a map of all the serpentine in California, and you can notice that it basically occurs in this belt from north to south, right right paralleling the coastline, which is where the subduction zone, the Farallon Plate, used to be. Now there's a San Andreas Fault there, but that the San Andreas Fault was born after the Farallon Plate was fully subducted. So all that serpentine was placed there in the last, I don't know, 30, 40, 50 million years, roughly. Okay, there's a bunch up here in Siskiyou County, right? So get some in Santa Barbara. You get a bunch in the Bay Area, a bunch inland on the other side of the Central Valley in the Sierra Nevada foothills. A lot of cool serpentine endemic plants. This is what some of those areas look like. I forget where this was. I think it was San Benito County, south of the Bay Area, but there's nothing growing there. There's a handful of pines. You've also got this summer dry Mediterranean climate, but you've got this toxic soil to boot. So this toxic soil, low in nitrogen and phosphorus and high in nickel and magnesium and iron. Excess amounts of iron is toxic to plants, right? Let's make sure this thing is still recording. Yeah, okay, there we go. Good. Just making sure it's not fucking up on me. I have to end up, cursing, freaking out. There's some chrysotile asbestos. Probably low grade, not going to hurt you unless you're doing lines of it, but you can see that shearing, which is a result of the pressure. So peridotite, which is a pretty dense rock, when it's cooked, it becomes a little bit lighter weight and less dense. And it becomes hydrated, and it becomes serpentinite. There's a whole wall of serpentinite. This stuff crumbles so easily. It is very brittle. It is very, you can't climb this stuff. It falls apart really readily. Okay, look at that. There's some beautiful chrysotile. Like you could see that stretching, that shearing. Okay, there's a serpentine plant community. Okay, the pines in the back are ghost pine, Pinus sabiniana. This is Calocedrus decurrens up here, incense cedar. Okay, that's not a serpentine obligate. It grows all over the Sierra Nevada as it grows up into Idaho, throughout the Intermountain West. Especially the Pacific Northwest, but it will tolerate serpentine, but it will definitely grow fucking stunted and dwarfed, as will many of these pines. And all this low-growing stuff is probably Camas adenostoma fasciculatum. It's in the rose family, Rosaceae. There's a Lewisia rediviva bitterroot, but an ecotype that is probably specific to serpentine. You can look at how the serpentine talus crumbles, right? Same size. It's blue rock. It oxidizes to red when it's been exposed to enough of the atmosphere and has undergone enough chemical weathering and exposure to rainwater, etc., it turns red. So some places like New Caledonia, where I'll show you at the end of this, what's probably going to be a very long slide presentation, New Caledonia is in a tropical environment, lots of rainfall, the soil is almost all red. Here's Hespero yucca whipplei. It used to be in the genus Yucca, but it's actually different enough from Yucca. It's still closely related to it. It was like the sister genus, but it's a world all its own. Really fucking cool plant. Grows on down into Baja California. There's another species in Nevada. But I think there's 2 or 3 species. But anyway, it's not a serpentine endemic, but it will tolerate serpentine. So there are some plants will only grow on serpentine, and some plants can just tolerate it. Right? There's a mushroom coming up. Not sure if that's mycorrhizal or saprotrophic. Who knows? But you can see the substrate is coming up. And these were Jeffrey pine, I believe. Pinus jeffreyi. They smell like, the bark smells like vanilla. And here they are growing on serpentine. And you get a lot of Pinus jeffreyi growing on serpentine in Northern California as well. Look at that. You can see basically pure blue rock. Here it's a little more orange. Wild. I don't know what this was. Yeah, that looks like, what was that? It was a calcium it was some sort of like magnesium. I forget the name of it, but I remember being at a spot in Baja and seeing huge clumps of this white stuff. If that was magnesium, some sort of sodium, magnesium, I don't know what the fuck. Anyway, here's a species of buckwheat growing on serpentine. Some more serpentine plant communities. You can see everything's low growing. There's not a lot of shrub cover nor a lot of tree cover. What was this? I wish I could remember what that was. I think that was a dwarfed oak. This is in, this is up in Mendocino County. You got this dwarfed phlox species. This is like 5,000 feet elevation. And Fritillaria glauca, which I don't know if that's a serpentine endemic, but you really get it a lot. It's a member of the lily family. You get it a lot on serpentine soils. There's up close of the flowers. There's Jactus in Napa County near Lake Berryessa. Scene of the Zodiac murders. Those red flowers are the flowers of a Dudleya species, and like a succulent. It's like a winter rainfall adapted version of Echeveria in the family Crassulaceae. And it's kind of blue and it blends in with the rock. And then when it needs its flowers to get pollinated, generally by hummingbirds or butterflies, they come out bright red. But you can see this whole hillside is all serpentinite. Really, really brutal for plants to grow in. Really, really cool environment to botanize in. There's the there's the flowers of the Dudleya. It's just Dudleya cymosa. This is another spot in Napa County. You can see how low growing all this stuff is. That is all probably camas, that Adenostoma fasciculatum. I think a fire came through and killed those ghost pines. You get a lot of ghost pines on serpentine. This is a true serpentine endemic. This is Asclepias solanoana, serpentine milkweed, a very rare plant, only known from a handful of counties in Northern California, and can only ever be found growing on serpentine. Basically, fully exposed on serpentine. Look, it's got kind of a prostrate habit, similar to Asclepias prostrata in southern Texas, which also is adapted to like full sun exposure, barren, sandy environments. This is a species of Phacelia, and I think there was a species of Aphelon in there as well. There's the flowers on at Asclepias solanoana, one of the most beautiful milkweeds. Look at that glaucous color. Pachyra greenii. This is a very common plant on serpentine. I've only ever seen it on serpentine. It's related to Senecio. It's in the family Asteraceae. It's got that glaucous color. That's the thing you'll notice about a lot of serpentine plants in California is they get this glaucous blue color and either heavy wax or heavy pubescence. Probably because they're just getting blasted by the sun and it's pretty dry and stressful where they grow. There's that Phacelia species, and here's a species of Aphelon. I think it was uniflora. It's in the paintbrush family. It's a parasite, parasitizing that Phacelia. Here is a species of Streptanthus. Oh, God, I forget what species this was. Christ. It's on my iNaturalist. If anybody is curious, if you go to Explore and then hit Filter Joey Santor and then type in taxon Streptanthus, it should be there 4 or 5 years back. A serpentine endemic growing in Napa County. Brassica family, Brassicaceae. The mustards, you could see those 4 petals. There's 4 petals in there, 6 stamens, and 4 sepals. Those green shits are the sepals. They've ever been called green shits before? Anyway, if not, now they have. This is, I believe this was Streptanthus breweri, another species of Streptanthus. Apparently, I was too lazy to put another photo in there to make it nice, so you could actually see the flowers. Mustard family, Brassicaceae. You get a couple Streptanthus species in Texas that are also rare. There's a couple others in North America, but the diversity in the genus is in California, and you get a shit ton of species diversity in Streptanthus on serpentine. I think serpentine tolerance has evolved, Christ, like 6 different times independently in the genus. Now remember, these plants can tolerate it, they don't need it. But the things that enable plants to tolerate serpentine are maladaptive on non-serpentine soils. So kind of once you go to serpentine, you can never really go back. All right, because the things that enabled you to grow on serpentine, like a tolerance towards heavy metals, etc., are not adaptive toward, in a normal, on a quote, normal soil. You'll get outcompeted. Right. So that's what they can tolerate the serpentine. They can't tolerate competition. And you get that with a lot of edaphic endemics, whether it's on gypsum or sand. I forgot to put in, there's a piece in this Gurovich's Ecology of Plant books, the Ecology of Plants books, which you can download on LibGen. The 3rd edition is the best, where she talks about heavy metal tolerance that was found in the UK on mine tailing piles on a type of grass. And yeah, it's fucking wild. It's basically the same thing that's going on with serpentine. This is where the hell was this? This was in Napa. Anyway, it's winter time, so these willows don't have any leaves on them. That was Salix breweri. It's a fucking dope willow, another serpentine tolerant plant. This is Pedicularis densiflora, growing on serpentine. It's also a parasite, but it's got chlorophyll too, so it's a hemi uh, a hemiparasite. It's not an obligate parasite. There you go. There's that paintbrush family Orobanchaceae. Beautiful plant. Supposedly you could smoke it, and it gives you a relaxing feeling. Which is actually I did that once. I smoked a joint entirely of Pedicularis densiflora, just the leaves, and I couldn't believe it. It was crazy. I was with my friend Cody. We smoked a joint of Pedicularis densiflora leaves, and it was like the most calming, soothing. It was surprisingly interesting. Yeah, but don't go out and rip a bunch out. Anyway, this is Fritillaria purtii, another serpentine endemic. I think this was in Humboldt. Another cool little lily. Lots of lilies, fritillarias. They're in the lily family, Liliaceae, have adapted to serpentine. There's a wall of Hespero yucca whipplei again on serpentine. This is all ghost pine, Pinus sabiniana, with an understory of Arctostaphylos glauca, which is you frequently encounter on serpentine. It doesn't need serpentine, but you really, a lot of times you find it there. Arctostaphylos it's related to madrone. It's in the blueberry family Ericaceae. It can probably tolerate serpentine. One of the reasons it can is that it's a ectomycorrhizal plant. So it forms associations with ectomycorrhizal fungi, but like all the arbutoid mycorrhizal plants, it actually lets the ectomycorrhizal fungi penetrate the root cortical cells. So ectomycorrhizal fungi behave like endomycorrhizal fungi in the arbutoid lineage of Ericaceae. More serpentine. This is near New Idria. It's a super fun site. Used to be this crazy old bastard that would come yelling at you whenever you drove by. Don't trespass on my land. Little flavor of Texas out in Central California. Guy's probably dead now. Probably gave himself an aneurysm from somebody trespassing on his land. But this was a mine site. They were mining cinnabar, which they would later use to produce mercury. Cinnabar is mercury ore. Look at that beautiful, barren, fucking weird landscape. Surface of Mars in some of these places. Really strange. Really cool. Look at that big block of. It's just a big block of this. Okay, let's see. Let me see. What is this? What's this doing? Okay, there we go. Just checking, just making sure you're still with me. What was this? This was a member of the carrot family, Apiaceae. These are some onions. A lot of cool allium species that have speciated on serpentine too. And there's a creek crossing. Where the fuck was this? I forget where this was. Oh, that might be Ryan O'Dell. That might be in I think that's Isaac and Ryan O'Dell. Yeah, this was in the central Valley serpentine as well. Pinus jeffreyi, little mimulus species, monkey flower. This was a Leisthenia species. It's a serpentine endemic. Some of the bitterroot flowers blooming. Ooh, nice. And all that. Again, just low-growing shrub cover punctuated by a couple pines that are also ectomycorrhizal that are able to tolerate that toxic, fucked up soil. This is all natural too. This is not a result of mining or anything. That's just what serpentine does. Desert serpentine. Okay, what it looks like in Baja California. Here we go. We're on the Vizcaíno Peninsula. There's an exposure of serpentine. So not only is it serpentinite soil, it's very toxic. It's also in a desert. So you've got a bunch of stressors there. All right, low rainfall and toxic soil. That's Alan Rockefeller way down there. You can see where it's up top, it's red, and then on the sides, it's blue. Why is that? Because on the up top, that layer's been exposed more consistently and longer to rainfall. It's had time to oxidize, where the sides are constantly eroding, and there's new talus falling down, so they haven't had as much time to weather. and turn red. Um, yeah, man, just a fucking wild. This is a really cool. Maybe that was magnesium carbonate that I saw there. Yeah, it was here that I saw one of those big white bubbles. Did I not put photos in there? It's like a big white. It was a rock that was like a big white, looked like a big white fluffy cumulus cloud. Definitely a rock I took with me when I left. Look at all this stuff, all this toxic shit. These are elephant trees here. There was a new species of milkweed vine in the genus Montilea, discovered here by John Redman. Hopefully he's described it, maybe not yet. This was what is it? Bahiopsis. Uh, it was a species of Bahiopsis. It used to be in the genus Vigiera, but it's Asteraceae. There was Eriogonum encelioides, a buckwheat that looks like an encelia. There was Eriogonum preclarum here. I can't believe I didn't put any photos of the plants. I guess I must have been in a rush. Rhus lentii. This is a sumac that's probably one of the most beautiful sumacs I've ever seen, and it is endemic to serpentine. It's endemic to ultramafic soil. There's some elephant trees, Pachycormus discolor in the Anacardiaceae, the poison ivy family. Anacardiaceae over there, poison ivy, mango, cashews, etc. It's a succulent. It's just a pachycorm. It's a succulent, a sarcocaulescent plant. It's got this big storage tuber. They do some weird. I mean, these can be 40-foot tall trees on good soil. Here, that thing's probably 100 years old and it's sprawling. Excuse me, all over the place. Really bizarre. Here this was my friend Susie, in a similar place. It was so nice. We camped in the truck there. I guess we were trespassing on some dude's land. The guy came out. He's like, "What the fuck you doing?" in Spanish. He just wanted to make sure we weren't, illegally fishing. And then was like, "You guys can keep camping there. It's fine. No big deal." That would never in a million years happen in Texas. They'd be a dick. Get the fuck out of here. Blah blah blah. This is mine. Really 9-year-old mentality. I just have to shit on the private property thing here in the state. Pisses me off all the time. Paranoid, delusional, nut job, angry people. I digress. I'm sorry. If you're watching this and you're one of those people that gets really upset about finding someone walking on your land looking at plants, well, I'm sorry. I don't know what to tell you. It's fucking, you're following the wrong channel, whatever. Anyway, so there we go. Number of cool plants here. And that Montilea, I thought it would be down in that new species. I thought it would be down in these washes. It was actually up top. Growing with these dwarfed elephant trees. Fucking wild landscape. So much cool shit here. It looks barren, but when you get up close and you're able to walk around and look at all this stuff, it's fucking wild. There's so much cool shit. There's a dwarfed elephant tree. Lousy photo of it. More dwarfed elephant trees. I should have put in those Eriogonum species. I can't believe I didn't include them. What is wrong with me? There's a Lophocereus schottii, the Sanita cactus growing on serpentine. Obviously, it can tolerate it. I don't know how, but that soil's toxic as fuck. Here's that new Montilea species, that new milkweed vine. Here's serpentine of New Caledonia. So New Caledonia, I should have put a map in here too. New Caledonia, for those that don't know, is a little island 500 miles off the northeast coast of Australia. It's basically a fragment of a continent. It's not volcanic like a lot of islands can be, where they're, in most cases, the volcano created the land that they're on sometime in the last 20, 30 million years. New Caledonia is actually a fragment of a continent. It's like a piece of a continent. And there was a bunch of weird tectonic action too. And some of the crust right there, instead of being subducted beneath the continental crust, actually got abducted, put, instead of going down, it got put on top of another piece of oceanic crust. So you've got the whole island is just a massive exposure of ultramafic soil and serpentine, and it's got some of the highest diversity in this genus, Araucariaceae, this genus of bizarre-ass conifers that evolved in the Triassic and is now restricted to the southern hemisphere. You get 2 species in South America. I think there's 3 or 4 in Australia, and like 13 in New Caledonia. And they've got this really weird look to them. The quote Norfolk Island pine, which you can buy in grocery stores around Christmas time, is in this same genus. And if you keep it in a pot, it'll grow to 3 feet tall. If you plant it in a yard where it's doesn't freeze. In a region where it doesn't freeze, you can get upwards of 120 feet tall. So anyway, this is Araucaria humboldtii right here. And here's Araucaria muelleri in the background. Fucking weird plants. More of what we're seeing, more what we saw in California, ultramafic soil and serpentine outcrops, okay? Weathers to red, otherwise it's blue. All right, but this is in a tropical environment. This is Cyathopsis albicans, Ericaceae, but it's in the lineage of southern hemisphere blueberries, the epacrids. It used to be Epacridaceae, now it's Epacridoides. It's a subfamily of the blueberry family. These cone-looking things are just flushes of new growth. It is such a fucking weird plant. There's another species there, Cyathopsis floribunda, which has bright red flushes of new growth. These white things are the flowers. Those blue things are just flushes of new growth. I don't know why it does that. It's fucking bizarre. The whole subfamily is bizarre. They've got parallel leaf venation. They look like monocots rather than blueberries. And then when you see the flowers, you're like, okay, I can see how it's a blueberry, but they're fucking so strange. And this thing only occurs on serpentine. I mean, the whole island is mostly serpentine to begin with, serpentinite. So New Caledonia, look it up. A lot of cool shit there. There's a lot of cool birds. There's no native mammals except for flying foxes. There's a ton of skink diversity too. Just a really weird place. It's got one of the oldest lineages of birds there as well, and the oldest lineage of flowering plant, Ambarella, which I didn't include here because it's not really a serpentine endemic. It grows on like lush forests. Anyway, there's more money shots at that Cyathopsis. You can see those little five fused petal flowers. There's some of the landscape. Look at it. Jesus Christ. Weird shit. This is a species of sedge, either a Costularia or a Gania. It's not a grass. Tons of weird shit everywhere here. And some of this stuff would weather from the constant humid. It's got a dry season, like most tropical areas, a dry season and a wet season. In the wet season, it rains so much. I think just at these lower elevations, you get all this oxidized serpentinite accumulating and turning into this hard, really weird, almost black, dark mahogany black rock. Nepenthes veillardii. There you go. That is a pitcher plant, obviously. One of the tropical pitcher plants from the genus Nepenthes, common among the collectors. They've all got different species of Nepenthes. Would you like to see my special Nepenthes? But anyway, no, seriously, and there's been a bunch of poaching of this genus lately, but this is a serpentine adapted one. It's a serpentine endemic one. I believe it's the only species of Nepenthes on New Caledonia. There's a shit ton in Borneo. There's maybe one or two. I think there's one or two in Australia. And as you get closer to the tropics, there's more. As you go further north, closer to the tropics. But that's just a modified leaf. Obvious adaptation to shit quality soil that's low in nitrogen is if you can trap, your nitrogen source, trap bugs, you're at an advantage. And there it is, just sprawling on the ground on that ultramafic soil. This is a species of Grevillea and Proteaceae, which is an entirely southern hemisphere family of plants. That's closest relatives are sycamores, which is weird to think about, but they go back like 80 million, 90 million years. So that's obviously going for bird pollination. Red flowers, those long things are the styles, the pollen presenters, and then the anthers are fused. They're fused to the four tepals, which you can't see unless you get close-up look. More of that Grevillea. You can see it's forming a large tree. More serpentine outcrops. This is a species of Dracophyllum, which is another epacrid, another member of Ericaceae. You can see they've got these dried, dehiscent fruits that have the seeds just come out. This is, I forget what species of Dracophyllum it was, but they're spiny. They don't look like blueberries at all. This is Cloesia floribunda, species in Myrtaceae. The Eucalyptus and guava family, which is very diverse in the southern hemisphere. And this was some species of orchid. This might be Eriaxis rigida, but these are just the leaves. But you could see what it's growing in. I put this photo here because you could see it's growing in like this fucking bright red oxidized ultramafic soil. Oh, Gymnostoma to Plankianum, Cassarinaceae. Okay, this is another family that doesn't occur in the northern hemisphere. They look like pines, but they're more closely related to oaks. They're in the order Phagales, and they associate with the nitrogen-fixing bacteria in the genus Frankia, just like alders and ceanothus and Comptonia peregrina, etc. And they form little root nodules. But this thing was so weird. It looks like a conifer. It's got this really weird habit to it, and it is abundant on the serpentine. These things that look like cones are just fruits. They're infructescences, and these little slits right here open up, and then a little winged seed comes out that looks like a pine seed too. It's really funny, but yeah, they're flowering plants. Love to get the photos of some of the flowers. There's a species that's like invasive in Mexico and lower latitude areas, Florida, California, etc. There's a species of Casuarina that some of you might know. Gymnostoma diplankianum, dope fucking plant, really weird. There's a close up. It's mimicking the araucarias in growth form too, and I don't know why. I don't know why this convergence on creating these whorls of stems and then no branches for the bottom 80% of the stem, and then just having this poof of well, those aren't leaves, they're photosynthetic stems in the case of Casuarina, but you know what I mean. Serpentine outcrop. Another member of the family Myrtaceae, the guava and eucalyptus family, Xanthostemon, Xanthostemon macrophyllus. However you want to pronounce it. Guava family. Look at that. Obviously going for bird pollination. Those long pronounced stamens and tons of nectar inside. More Grevillea. This was Grevillea exul, Proteaceae. That green thing is the stigma at the end of that pollen presenter. And you can see those curled back things. Those are the four tepals. Remember, if there's no differentiation between petals and sepals, there's only one series, it's tepals. There's that plant, Grevillea exul. Fucking dope plant. That's Dracophyllum. This was Dracophyllum. I think it was fasciculate. What was it? Dracophyllum. It's one of the more common species. I forget the name of it. But either way, that's a blueberry. Ericaceae. All right. Epacrodoides subfamily. Fucking nuts. Yeah, it's got the Nepenthes hanging on it. It's just absolutely insane, man. There's more of that landscape. There's a Costularia species, Cyperaceae, Myotocarpus. I think that whole family is endemic to New Caledonia, and it's a sister family to the carrot family, Apiaceae. It's in the same order, and it's more closely related to Apiaceae than the English ivy family, Aureliaceae, is, which some of you might know. Anybody who's up under plant taxonomy and systematics, Aureliaceae is sister to the carrot family. You can see it in that flower structure, right? When you've got this compound umbel, or in this case, I guess it's just an umbel. Well, no, it's like a panicle with umbels on them, I suppose. Fucking weird. All right, here is a whole host of cool plants. You can see this black rock. Looks like, Jesus Christ, I don't know, gabbro maybe? Obviously a product of a subduction zone. A lot of iron in there. And here is Agathis ovata, which is another member of the Araucariaceae, the monkey puzzle family, that Triassic age lineage of conifers. This is a severely dwarfed one. They can get a little bit taller than this. Here's that Dracophyllum again, Ericaceae, that looks like a bromeliad, but it's actually a blueberry. There's Myotocarpus back there. There's Cunonia back there. Tons of weird shit here. Just mind-blowingly cool. Stromatopterus moniliformis, which is in the family Glyciniaceae, the forked fern family. Just coming up amongst all this old rock. I didn't even realize somebody stacked rocks there. Shit, I should have kicked it over. There's that fern. Bizarre. To me, it looks like it would be, one of the chylanthoids or something. But obviously, those spores, those sori, are different. Those clusters of sporangia. Fucking weird. There's Agathis ovata. See, that same species as that dwarfed conifer I showed you 2 slides back, but there's a big one. And there's Dacrydium araucarioides, which is in Podocarpaceae, another weird and bizarre family of conifer from the Triassic. And there's Agathis ovata. And look how dwarfed all these plants are. It's because they're on ultramafic serpentine soil. So these conifers are probably doing this with the help of mycorrhizae. They're probably getting this size with the help of mycorrhizae, but still they're probably very slow growing and very old. Look at this shit, man. Crazy. Such a cool habitat. There was so much good stuff to see there. Araucaria bernieri. You can see it's actually like forest down there on the bottom. Love to go see Borneo, see the shit that's there. God, there's ultramafic lifestyles of Borneo. You get really high elevations there. You don't get too much elevation in New Caledonia. I think 6,000 feet's the most. Drosera neocaledonica. Look, it's got hairs on it, flushing bright red. So a Drosera, this is a Drosera that made it to New Caledonia and is a New Caledonia endemic and frequently grows on ultramafic soil. There is some heavily weathered ultramafic soil. Take one look at that and tell this is a tropical environment. All right, serpentine doesn't do that in California. All right, Megastylus gigas, an orchid you'd frequently see growing on ultramafic soil, right, all over the place. I mean, really, the name of the habitat type there is called maquis, Maquis, on that ultramafic stuff. And you would see this all over the maquis. You'd see Megastylus gigas, and also I think Ariaxis rigida there as well. This was some of the coolest stuff. This whole habitat, God, the mosquitoes were bad. I think they were breeding in the leaf blades, the Dracophyllum, which would hold water. This was a really cool grass called, God damn it, I can't remember the name of it. It'll be in my iNaturalist if you go look it up. But this is all low growing maquis. Nothing can get too tall here. You could see there's the rock right there. It basically, the rock up close. Look at all the iron in there too. You crack it open, and then you look at you can see the olivine and pyroxene in there. All those in the minerals that are formed by them. I don't know if that's lizardite or what, but it's all those serpentinite minerals. I mean, just wild fucking geology, and so evident that this is a really tough place to grow if you're a plant. I mean, you can't get that tall. You're inhibited by lack of nutrients and this toxic soil that's abundant in heavy metals like nickel. There's an orchid. No, that wasn't an orchid. God damn it! What was that? You know what? I'm gonna find out that name. The name of that genus. What was it, man? It was on the tip of my tongue. This happens all the time. I'm getting tired of this stuff happening. Gracelania circinata. Yeah, there you go. Gracelania. Greslania. All right. Anyway, let's see. Okay, Gracelania circinata. All right, that was a fucking cool. Was that a bamboosoid? I feel like it was. Was it in the bamboo subfamily? Let's see. Got that? Yeah, bamboosoidy. Not surprising. Looks like a bamboo. This is another gymnostoma species. That I don't know why that photo came out like that, but that's the maquis. Ericaria humboldtii. I was there with the guy who was studying this because a lot of them are dying from some introduced fungal infection that's doing this to the branch tips, kind of like eating the scales. Look at those imbricate scales on that. They feel like plastic too. This was all fucking incredible. Just some dope plant life there. Low growing. Look how dwarfed these Araucarias are. These can get a lot bigger than this. This was 6 foot tall right there. But if they're in on a deep soil and not on bare serpentinite, they can get upwards of 60 feet tall. This is another cool one. Libocedrus yataensis from the redwood family, Cupressaceae. Look at that beautiful blue foliage. This thing was it was more common in like a denser forest, not tall forest, maybe 20 feet tall at most, but a denser forest where there was a thicker soil. There's also a couple of Libocedrus species on New Zealand, and I think there's one on New Guinea, but that's it. This whole genus is a southern hemisphere. Cupressoid, Pancharia hirsuta cunoniaceae. Look at that leaf shape. All right, convex. All right, convex upward to. So water will be shed off of it, and then it's got an indumentum, like this pubescence on the underside for that long dry season. So it's cupped like that. You'll see those similar traits in a lot of tropical environments with dry seasons, so that they can shed water during the wet season, but not lose too much moisture through their stomata because they've got hairs on them during the dry season. This is a super tiny orchid, Porpax, caracuyensis. Everybody give a shout out to Porpax. Fucking came up with that genus. Are there other species in that genus, I wonder? I don't know. Anyway, this thing was tiny. It was growing in this bed of moss epiphytically. and the moss was in turn growing on some sort of rare palm. This was a wild one to see, and it apparently liked the McKee, Homelium austrocaladonicum, willow family, Salicaceae. Fucking cool. Look at those tassels. Look at those big, broad leaves. I believe I did get an herbarium specimen of this. That was a really cool plant. Zeronema morii, doing the brush inflorescence structure that same thing you'll see on the genus Cunonia, like on Cunonia macrophylla. This brush inflorescence, which is and along with the red color, an adaptation to bird pollination. But you can see it's a monocot. It's in Asparagales. I think it's in its own family, Zeronematacea. Ericaria Muelleri, after some dead guy named Mueller, who nobody remembers. There's the habit. What a fucking cool plant. Again, what a weird way for I wonder how it would grow on, quote, normal soil, if it would have the same candelabra shape or if it would get more of a mushroom shape like some of the other Araucarias. Anyway, that's it. So how do plants speciate onto serpentine? Let's actually, I should put this up there now. Let's get to that because I got a nice drawing that kind of illustrates how that happens. And when I learned about this was one of the best examples of plant evolution. Is this not going to do it? Oh my God. There we go. Okay, cool. One of the best examples of natural selection. So you've got normal soil, quote, normal soil next to a patch of serpentine soil. And that serpentine soil is acting like a filter. It's telling what is going to grow. It's deciding what's going to grow, right? So these plants on non-serpentine soil are constantly casting seeds. They're casting them everywhere, but some of these seeds are going onto the serpentine soil, the serpentinite soil. As I've indicated with these little cartoon skulls, a lot of these seeds that germinate won't be able to survive because they can't survive the toxic soil. Regardless, you've got this continuously casting seeds. This is an easy way to think about it, okay? For purposes of understanding the concept of edaphic endemism and speciation as a result of geographic substrate, these plants are constantly casting seeds onto serpentinite soil, and most of the seedlings, if they germinate, will not be able to survive. But a couple will. And why is that? Because there's constant phenotypic change as a result of genetic recombination, i.e. sex. And so, at some point, new phenotypes will evolve in the form of seeds, and one might be able to survive, and then so goes the selection. It's made it through that filter. Literally made it through that filter of the serpentine soil. So we can think of evolution as a filter. So I'll put this other thing up there, which I should have done already, and I apologize for not. This other drawing, okay? Let's see. Okay, a population, and it should say under here, consisting of different phenotypes. All right, so let's actually do that. A population consisting of different phenotypes undergoing selection by something in the environment. In this case, it's serpentine. Okay, in the case of the serpentine that was in the desert, it's that filter would be serpentinite soil and low rainfall. But phenotypes are the phenotypic change is the raw material of natural selection, right? So this is kind of, in this case, think of serpentinite soil, as the filter, okay? Okay, but so the filter is the selection pressure. It's the force of selection. Could be in the case of if this wasn't about serpentinite, that selection pressure could be a change in climate, like a mountain range goes up and it shades the certain area, it creates a rain shadow, so that suddenly the spot on the west side of the mountain is not getting as much rainfall as the population of the same species on the east, and so that population on the west ends up evolving, if it doesn't go extinct, evolving into a more drought tolerant species, perhaps evolving smaller, narrower leaves or hairs on the leaves, etc. But in the case of serpentine, the serpentinite is that filter. And so eventually what happens is most of the seeds don't survive, but those that do then are able to So they've got the alleles, the copies of a gene that enable them to tolerate the high nickel content and the lack of nitrogen. And now they're already selected. They've undergone selection. So now they breed and they produce seeds, and half those seeds will have the alleles from the old population on the normal soil. They're not going to survive, but half, just throwing random numbers out there, it's probably smaller than this. Half will have the alleles that code for serpentine tolerance, and those will be able to survive. And then you drag this out over 1,000, 10,000, 50,000 years, whatever, and you get a new species. And they can no longer interbreed. Okay. Or maybe they can interbreed, but again, since even any of those alleles that are inherited or acquired from the population of plants in the quote normal soil, just those alleles are not going to enable that plant to survive. And so the serpentinite is just constantly selecting for serpentinite tolerance. And then probably eventually they just get to the point where they're just too different of species and they can't hybridize anymore and breed. The point is, you get a new fucking species evolving in response to this serpentinite soil. And you get the same thing with limestone, because limestone can be harsh for plants to grow in. Okay, high calcium content, low nitrogen content. Every farmer probably knows that, farming on bare limestone, bare limestone is impossible, or even thin soiled limestone is hard. That limestone, limey soils can be problematic for plants. Right, too much of a good thing. Same thing with gypsum, which is really harsh for plants to grow in. You get gypsum endemics, whole suite of gypsum endemic cacti in Nuevo Leon. Okay, so there is you can see how this happens. It's not just serpentinite. Serpentinite's the easiest one to think of because it's such an extreme, but there's also sand dune obligates and laterite soil obligates and whole suites of plants that occur that are edaphic endemics. So really fascinating fucking phenomenon. If you're interested in this, I encourage you to read, download that Ecology of Plants book. If you're in that book and you search, oh, there it is. It is page 251, and it's about Achillea lanulosa. That uses the model organism to explain ecotypes. Oh, wait, this is something different. That's ecotypes. Where's the fucking piece about toxic soils? Oh, here we go. Page 241. I'm sorry. I'm getting all confused. 9.3 patterns of adaptation are the result of natural selection. And then there's a whole piece on heavy metal tolerance and how it was seen that this plant, Agrostis tenuis, it's a grass, literally evolved, a new subspecies evolved within the span of a century or two from just on mine tailings in the UK. Fascinating shit, really cool to think about, and it gets you thinking about a whole host of other subjects relating to natural selection and how things speciate to begin with. Anyway, man, I should have put those. I can't believe I didn't put those Eriogonum photos. Any of the other cool plants from that Baja serpentine. I'll have to do another piece on serpentine soils. Maybe we'll do a live stream or something. But anyway, all right. Well, hopefully you got some out of that. Have a great day. Go fuck yourself. Bye.